In this example, we're going to work through and find the exact value for the tangent of 18 degrees. And as a consequence of the process we're going to use, we're also going to find the exact value for the tangent of 54 degrees as well. And so you'll see over here on the right, I've included a few trig identities. All of them are for tangent. So we have the double angle identity, the triple angle identity, and the difference identity here. Okay, so let's get started. I'm going to start by saying x equals that 18 degrees that we're looking for. And so I've created a nice equation so we can use the properties of equality and manipulate this equation. So let's start by multiplying both sides by 5. And so we'll have 5x equals 90 degrees. And so I'm going to start by splitting this 5x now into a 2x plus a 3x. And I'm also going to split this 90 degrees into a 45 degrees plus a 45 degrees. And the reason I need to do this 45 degree split right here is because the tangent of 90 degrees ends up being undefined. So I'm going to have to take kind of a sideways approach to this. Okay, let's rearrange a few of these terms. I'm going to bring the 45 degrees over here and the 2x over here. And so I'm going to end up with 3x minus 45 degrees equals 45 degrees minus 2x. Okay? So finally, to kind of wrap up this part of it, I'm going to take the tangent of both sides of this equation. So you'll see on the left and the right-hand side of this equation, I'm going to have this difference identity for tangent. So what we're going to do is go ahead and use this difference identity for tangent and expand both sides of this equation. So let's start here on the left. So we'll have the tangent of 3x minus the tangent of 45 degrees. And probably you can already see why I split it up into 45 plus 45, because the tangent of 45 is just 1, and that's nice. And it'll be 1 plus now the product of the tangent of 3x and the tangent of 45 degrees. And that, of course, will be equal to the tangent of 45 minus, the tangent of 2x all over 1 plus the tangent of 45 degrees times the tangent of 2x. So at this point, there's a few things that I can do outright. Let's go ahead and take these tangent of 45s and make them all 1. So this is the tangent of 3x minus 1 all over, and let's see, this multiplication by 1 here can just go away. And let's go ahead and switch the order of these two terms. So I have the tangent of 3x plus 1, just so I can have this similarity in the numerator and denominator. And so over here on the right side, I have a 1 minus the tangent of 2x. And that's being divided by, and that's a multiplication by 1, so 1 plus the tangent of 2x. Okay, so I'm not going to use the double angle and triple identities quite yet. I'm going to go ahead and do the cross products first and multiply through here, because you're going to see some things and some terms will cancel, and it's going to be actually quite nice. So let's do this multiplication. So I'll take this binomial times this binomial. So it looks like we have the tangent of 3x plus the tangent of 2x times the tangent of 3x, and this is kind of the long part here, and then minus 1 minus the tangent of 2x. Okay, so that's this cross product, and we're going to set that equal to this cross product, which let's do parentheses again. So tangent of 3x, and then we have minus the tangent of 2x times the tangent of 3x plus 1 and minus the tangent of 2x. So this is an equation here. It's this left side equaling this right side. And so you'll see automatically the tangent of 3x's cancel out and the negative tangent of 2x's cancel out. So that was really nice. So rewriting this, it looks like the tangent of 2x times the tangent of 3x minus 1 equals, and then basically it's those same terms except they have opposite signs, which will be nice because then when we move these over to the left side, the sign here and here will change. So we'll basically just have 2 tangent of 2x times tangent of 3x minus 2 equals 0. But of course, when you factor a 2 out, you can divide both sides by 2 and cancel those. So what we have here is the tangent of 2x times the tangent of 3x minus 1 equals 0. Okay, this is a great place to be right now because we took something that had the potential to be very, very ugly and we simplified it quite nicely, actually. Okay, so here we have the tangent of 2x and here we have the tangent of 3x. So this is our double angle identity and triple angle identity. So let's go ahead and replace those with these expressions. So our double angle identity is going to be 2 tangent of x over 1 minus tangent squared of x. And our triple angle identity will be 3 tangent of x minus tangent cubed of x all over 1 minus 3 tangent squared of x. Of course, that's minus 1, and then that equals 0. So I'm going to go ahead right now and make our lives a little bit easier. I'm going to do a u substitution and say u is going to equal the tangent of x. So instead of having to write tangent of x over and over and over again, let's just use a u instead. So now I have 2u over 1 minus u squared times, and it looks like this guy will be 3u minus u cubed over 1 minus 3u squared. That's minus 1 equals 0. So it looks like we can get some common denominators here and make this 1 into the denominator over denominator. And it looks like the common denominators are just going to be these two rascals multiplied together. So let's go ahead and put parentheses around everything and see what we have. So 2u times this 3u minus u cubed minus, and then this denominator, okay, and that equals 0. And now that we have this common denominator, I actually don't even care about the denominator anymore because as long as the numerator equals 0, then I'm good to go. Okay, so let's go ahead and multiply all these terms out and see what we have. So it looks like 6u squared minus 2u to the 4th minus 1 plus 3u squared plus u squared minus 3u to the 4th equals 0. And that's foiling through here and including this negative as well. So let's combine like terms. Looks like we have a negative 5u to the 4th, and then 6, and let's see, plus 10u squared, and then we have just that 1 right there. And I don't really like this leading coefficient being negative, so let's make it positive. So 5u to the 4th minus 10u squared plus 1 equals 0. And so here we have a really nice polynomial equation that came from, well, all the stuff we've done to this point. So let me go ahead and grab a new sheet of paper because I'm out of paper, and we'll start again. So looking at this polynomial equation, it looks like we can use the quadratic formula to solve it because our degrees are 4, 2, and 0. So this term in the middle here is u squared. So we can say u squared equals, and then use that quadratic. Okay, so our a value looks like it's going to be 5, our b value is negative 10, and our c value is 1. So we have the opposite of b, so 10 plus or minus the square root of, so b squared is 100 minus 4ac all over twice a. Okay, so that's all that out there. So 100 minus, it looks like this is 20, 4 times 5. So 100 minus 20 is 80. And I can reduce the square root of 80 to, let's see, 4 radical 5 all over 10. And I can factor a 2 and cancel it out of everything. So 5, 2, 5. So it looks like 5 plus or minus 2 radical 5 all over 5. And that equals u squared. And remember, if you will, that this value of u is tangent of x, and x was 18 degrees. So solving for u will give me the exact value here for the tangent of 18 degrees. Well, let's do the square root of both sides here. And in doing so, that square root and the squared cancel there. And we also need to include this plus or minus over here on this non-perfect square side. Well, which of these are we going to use, though? Let's see, tangent of 18 degrees. Well, 18 degrees is in the first quadrant where tangent is positive. So I'm actually going to use the positive version of this and not the negative. So I can just ignore that because it's going to be positive anyway. Okay, so let's kind of look at this as far as the square root of 5 plus or minus 2 radical 5 all over the square root of 5. And we can go ahead maybe and rationalize that a little if you'd like. Anyway, so we have our value of u here, and it's the square root of 5 over 5 times this radical expression, 5 plus or minus 2 radical 5. Well, herein lies the problem. So we have a plus or minus in here. How do I know which one to use? Well, the tangent of 0 degrees is 0. And the tangent of 45 we've already seen is 1. So in between 0 and 1 should be the tangent of 18 degrees. And so when I use the plus here, I'm going to end up with a decimal value that's bigger than 1. And when I use the minus, it's going to be between 0 and 1. So I can say here the tangent of 18 degrees is the square root of 5 over 5 times the square root of 5 minus 2 radical 5. And here is my exact value. We'll grab a calculator here in a second. I'll show that to you. But also, as promised, the tangent of 54 will come out of this equation as well, because that guy will be when I use the plus right there. So here are two exact values for tangent that we got from solving one equation. So let's go ahead and grab a calculator and I'll show you that this works. Okay, so here is our calculator. We'll kind of move things over a tad here so we have some room to work. And so let's go ahead and do that first one. We'll do inverse tangent and we'll put that expression in there. So we have the square root of 5 divided by 5. And we're going to multiply that by that square root expression, and we have it right there. So let's close off those parentheses and equals, hey, 18 degrees, yeah. And so if I go up here and change this minus to a plus and do the same thing, yeah, that's where our 54 degrees comes from. So that plus or minus in there actually gave us two separate values for the tangent. So here we go, kind of a long process, pretty algebra heavy in those middle steps there. But we were able to get that polynomial equation. That was really nice, and we solved it using the quadratic formula. And we found the exact value for both the tangent of 18 degrees and the tangent of 54 degrees.